Good afternoon, good evening, everyone, and thank you all for joining us today for our webinar on visualizing and analyzing your Neo4j data with Tom Sawyer perspectives. I want to thank Tom Sawyer for joining us. We're going to be partnering up with them for Graph Connect as well, so I'm really excited about that. So in this webinar today, we have Joshua Feingold, who is the Head of Solutions Engineering for Tom Sawyer Software, and we also have Ryan Boyd, who's Head of Developer Relations here at Neo4j. We realize that some of you are going to be coming from the Tom Sawyer side and some are coming from the Neo side, so we're going to do an intro to Neo4j to kick it off with Ryan, and then we're going to hand it over to Josh for some more on visualizing and analyzing your data. Just a few housekeeping notes before we get started. We are recording this session and it'll be sent out via email to everyone who registered either tomorrow or early next week. And we'll also post it on our YouTube channel, www.youtube.com/neo4j, which also has all of our previously recorded webinars on there as well. And I believe the Tom Sawyer folks are going to post that on their channels as well. And then secondly, we are going to be taking questions. We'll reserve them for the end of the session. However, you can ask them at any time by typing them into your questions portion of your GoToWebinar control panel. And with that, Ryan, do you want to kick it off?
Yes, great. Thank you, Greta. Hello, everyone. My name is Ryan Boyd. I'm on the developer relations team here at Neo4j, and I wanted to give you a brief intro into graph databases and the power of graph databases and Neo4j. And then, like Greta said, I'll be turning it over to Tom Sawyer, and Josh from Tom Sawyer will be talking about using their visualization tools on top of it. So the first thing I want to talk about is the graph data model. Well, like this actually doesn't look like a graph, obviously, but how many of you, use relational databases on a regular day? You probably most of you do. And those relational databases store data as columns and rows. And most other database technologies do take these two ideas as well of storing data as columns and rows. But, it's not really a natural way to think about your data. So if you think about, in this case, a person and then a relationship between two people, in a relational database, you would have two tables. You'd have the person table and then the person-friend relationship table. And then you would have a mapping in the person-friend relationship table between different person IDs. This may be intuitive to those folks who have done relational databases for many years. This may be intuitive, to a handful of developers who have not done relational databases for many years. But to the average person, this isn't really an intuitive way to store and reference data. It's something that needs to be learned. And then it creates a communication barrier between software developers and the business folks they're working with. So we want you to think more like this, and we think it's a much more natural, intuitive way to think in terms of nodes and then the relationships between nodes. Or think of it as objects and the relationships with objects. So, or between objects. So in this case here, we have two different companies. We have Acme Company and we have Jupiter Tech. And we're looking at their organizational structure and their relationships between those two companies. And the relationship very much looks like a graph. The organizational structure may at times be a tree, and at other times, if you have a multi-reporting relationship, may be much more graph-like. And in this case, obviously, we're showing the relationship between these two companies. But this is a much more intuitive way to think about your data in the graph model. So what does that look like? Well, here is a quick diagram of the graph model. In this case, we have Andreas as a person who knows three other people, Tobias, Micah, and Delia. And these three other people are connected to Andreas by this knows relationship. So it's a relationship with a label of knows. And within each of these, we're going to talk about how you can store properties and additional data as well in a graph database. So my goal today really is to convince you, first of all, that graphs are a more natural way to store your data It's more intuitive to think about your data in terms of graph, structure your data in graphs, and then query your data in graphs. And then two, that graphs can be much more efficient for some types of use cases. So the property graph model looks something like this. We have nodes, and then what I just popped up here are the properties on those nodes. So in this case, we have two people nodes or person nodes. They have properties name, Dan, and Anne on the right-hand side, and then they have the date of birth, for both of these person nodes. And then they have a Twitter handle for Dan in particular. So Neo4j is schemaless. You can modify the objects at any time and add additional properties or delete properties. It gives you that flexibility that as your business changes, you can update your graph to reflect those changes. So we can see here that Dan has an additional property that Anne does not have, and that Dan has a Twitter handle. And then we see here the relationship, so loves. So Dan loves Anne, and luckily for Dan, Anne also loves Dan back. So that's a good relationship here. Then we also show that Dan lives with Anne. And these are directed relationships. That's how Neo4j stores relationships, is in a directed fashion. In the case of this loves relationship, you don't necessarily need to put both relationships in both directions, because in Neo4j, although it is a directed relationship, you can query on both directions, regardless of what the actual direction is of the relationship. That is a much more performant way to store this data, or a better optimized way to store this data would just be a one loves relationship. Perhaps the person who first asked the other person out is the originator of the relationship. Okay, so then we have an additional node here called a car, and that car is the label for that node. And then we have some more relationships. And you'll notice on this drives relationship, we have a property on the relationship as well. Think of this as in a relational database, you have your join tables, and you might have additional properties on the join. And then you would put it in the property on a relationship in a graph database. So, Dan has been driving the car that is owned by Anne since January 10, 2011. And I wanted to talk a bit about that performance as well. Is one of the key values of a graph database is high performance queries of relationships. And the way that you get high performance queries of relationships is by what we call index-free adjacency. It means basically as you traverse the relationships between nodes, essentially it is just doing some basic pointer arithmetic, either on disk or in memory, to find the node that another node is related to. It's not having to look that up in an index. And so in a relational database, every time you do a join, and oftentimes we've seen customers with dozens of joins in their queries, it's looking up in different indexes in order to find the next bit of data. And that's an expensive operation, certainly much less expensive than a full table scan, but still much more expensive than simply doing this pointer arithmetic that we do in Neo4j. So we're storing the data on disk essentially as here's a node, here's a relationship, and the next relationship is 300 and some odd bytes later or something along those lines. And that allows us to quickly traverse the graph and allows us to put relationships at the forefront of our data model. So why does that matter? Well, I'm showing here a picture from our Graph Connect conference. This is our main conference for Neo4j users and prospective users. And on stage here is a gentleman named Volker from eBay. And he's from the eBay real-time delivery service. And they actually previously used a MySQL relational database to route packages between their stores as well as the individuals. So what happens when you place an order with them is they find a courier essentially to go to a store, pick up that item, and then deliver that item to you as a person. And they want to find who's the best courier, what's the best store, you know, what the route is that they should take. And previously, with their relational database, the longest query to figure out the appropriate route was actually longer than their shortest delivery time. So they were actually finding it really hard to do an efficient query of their data to route packages. And then they switched to Neo4j, and because of the properties which I just talked about of how we store the nodes on disks, it was actually much faster for them to run Neo4j. So they were able to much more efficiently route their packages. And this applies to a lot of logistics customers that we have, the same sort of way of routing packages or routing containers on container ships, and other types of logistics challenges. So, and you know, Volker demonstrated this at our GraphConnect conference by actually having a bottle of whiskey delivered to him during the talk, which kind of surprised everyone. I don't think anyone from our staff actually planned for that. So I think the whiskey delivery man got stopped at the door. But anyway, the moral of the story is if you like whiskey and you want your whiskey delivered faster, you can use Neo4j. And here's a quote from Volker saying, you know, we found Neo4j to be literally thousands of times faster than our prior MySQL solution. And then an important point here is that their queries required 10 to 100 times less code. So it's a lot more maintainable. They can write their software, and their developers can understand their software better, and it's a lot more maintainable as they go forward over the years and have different staff come on board. And that reminds me here, so GraphConnect, our conference that I just talked about there, Volker was presenting, is open for registration right now. It's at the end of October, I believe October 21st in San Francisco. So go to graphconnect.com if you would like to register for that. The tickets are relatively cheap, and it is a very good experience that we cover a lot of ground, both for experienced Neo4j users as well as people that are new to Neo4j and graph databases. So let's talk about how you can run Neo4j. We've talked about kind of what it is and the value that it provides, but how do you run it? How do you actually use the Neo4j database? Well, there are two ways. We originated as a Java, piece of Java software where it runs in an embedded mode, and you have a Java traversal framework. So you can write your Java code to traverse the graph, and we handle all the underlying storage and transactions and all of that. But you can write this, write a Java application to traverse it and embed it with that Java application. That's been sort of the traditional way of the past. But more and more, we're seeing our customers and our prospects be much more interested in the second way, which is a server mode with a REST API and then a Cypher query language. You'll see Cypher query language here shortly. Cypher is very similar to something like SQL. It's a way that you can describe your queries in a syntax that's easy to read and understand. And then a REST API, so you can just communicate it over HTTP from any programming language, whether you're using Python or Ruby or C# or Java, you can communicate with the Neo4j Cypher protocol, or sorry, Cypher syntax over the REST-based protocol. All right, let's go into a little bit about how you can query your data. First of all, here's a super basic query when we know exactly what we're looking for. So in this case here, we're matching employees, that's our label of the node, their employee nodes, with a property of first name, in this case Stephen, and the reports to relationship, and finding the employee with a first name of Andrew. And you can see here that there's like the dash before the relationship and the arrow after the relationship. And really we call this ASCII art for graphs, or ASCII art for querying. It's really a way to express your queries that is very intuitive and readable by anyone. So we're seeing here finding an employee who reports to in a directed style to another employee. So here is it in a slightly different format. In this case, we are looking at a skills database of employee skills, and we're trying to match a user who has a skill labeled as S, the U1 and the S and the U2 in this first query, as well as the HS1 and the HS2 are all sort of aliases that you can use then to refer to the nodes or relationships later on in the query. So we're saying, find me a user who has a skill, S, and then find me a second user who also has that skill. And that's our match clause. It's really just kind of trying to find a pattern in the graph. It's specifying what the pattern is that we're looking for in the graph. And then the where clause really anchors that pattern. It says, what are our starting points for traversal, and what are the restrictions that we should place on that traversal? So in this case, we're saying we're going to start really at a node with a name of Jane, and then we're going to restrict our traversal to only look for people who have skills that are similar in the level to each other. We don't want to have people that have a skill but at vastly different level when we return the results of this query. And then you can see the return clause here. It looks very similar to SQL. So here's another example using our movie data set that is included in Neo4j. When you download Neo4j, you can actually get started with Neo4j in little less than a minute, including the time to download, install, and get the Neo4j browser up and running. It's pretty awesome that way. And this data set might take you another minute to populate going through our tutorials. But the data set includes how movies have actors and directors and how all of those are related to each other. And if we wanted to find all the people who are both actors and directors in a traditional SQL database, we would do something like this, where we have two sub-select statements querying from the actor and director table, and then the outer SQL statement is querying from the person table. In Cypher, it's a little bit more intuitive here. We have a match statement. We're trying to find people where the person acts in a movie and the person directs in a movie. And because we're not using the same aliases here, we're saying, and the person directs in any movie, and return the person's name. So a very simple statement. I'm going to skip over this one for now, but we'll send out the slides, just looking at time here. Here's a real world query from a customer though. We had a customer come to us and say they want to find all direct reports in their organization to a particular VP or something like that, and how many people those direct reports manage up to 3 levels down within the organization. Fairly simple query to express in English. When they tried to express it in SQL, they came up with something like this. And I believe I have an 8-point font on this slide. Obviously, I don't expect you to read this, but this is the query that they were actually running, which was a bunch of union statements of very similar queries to go down each level in the tree. And if they added additional levels to the organization, they would need to add these union statements, and it just was not very maintainable code. Now, I'm sure that there's a way for super SQL experts to optimize this query a bit, but the reality is that many customers don't have the optimized versions of queries like this running within their organization. They are, using SQL as their logic dictates from their past experiences. So if you could convert something like this to a query that takes up much less of this page on the slide or the space on the slide, this is the Cypher query. Again, more intuitive. Find me a manager who reports to a boss, and then the report who reports to the manager, and we can see the levels here up to 3 levels deep. And you're finding, where the boss, or let's say the vice president, his name is John Doe, and then returning their manager that's in their organization, as well as the count of total reports. Much more intuitive way to express the query, than this page long of 8-point font. And I actually cut off the query here. There's another, I don't know, 10 or 15 lines. All right, so I want to talk to you about how you get your data into Neo4j. We talked a little bit about querying and the Cypher query language, which you can use over a REST API from any programming language, and there's drivers out there for Python, Ruby, Go, C Sharp, a lot of different languages. But you need to get your data into Neo4j in order to start querying it. So how do you get your data in? Well, the most common way of getting your data in is like what Tom Sawyer did with the data set that they're going to be talking about here shortly. And this data set is commodity flow data. What that means is we're looking at various commodities, such as live animals and fish, to fertilizers, to chemicals, to coal. We're looking at those commodities and seeing how those commodities flow between different areas of different states. And the way that we have that data expressed, when Tom Sawyer downloaded this data as a public data set, they got a bunch of CSV files, or it might have started off as Excel files, but in the end, CSV files is a very common way to store data. And so they have CSV files for commodities. So these are all the commodities objects which will be converted, or commodities rows which will be converted to commodities nodes within Neo4j. Then they have state objects, and then they have areas, and you'll see here that there are multiple areas per state. So if you're in Alabama here, we have the general Alabama area, as well as we have some other of the metropolitan areas for different parts of Alabama. And so then we have the commodities, as we showed you, and then commodities flows, which basically expresses how the commodity flows between these different areas and how much tonnage and things like that flow between these areas of these commodities. So very simple data expressed as a CSV, and then they wrote some Cypher queries. So Cypher, in addition to being used to run your queries on your data in Neo4j in a live way, Neo4j is an OLTP with ACID compliance and all of that. In addition to be able to do that, it also allows you to express your data that you want to load into Neo4j. And so here's some examples. The top query here basically says load CSV with headers from a location. In this case, it's a file that's on our local disk, but we can also load it over HTTP. And then we're creating here state nodes. So we're creating nodes labeled with the word state, and we're specifying the different properties of those nodes, a code and a name. And so that's fairly simple. And then the next one shows a little bit more intricate version where we're creating area nodes, and then we're matching the state that area represents, and then creating the relationship between a state and an area. And again, you can see how intuitive this sort of ASCII art for graphs is. The way that you express your create queries in Cypher is very similar to how you would express a query to search your data. And so, with that, we've shown you how you can query data in a graph database, what the benefits of a graph database are in terms of intuitiveness and performance, and we've shown you how to get your data in and query it. So now I'm going to turn it over to Josh from Tom Sawyer, and Josh is going to talk about how you can visualize and analyze this data. So Josh, feel free to take it from here.
All right. Looks like we're just waiting a moment to get the presenter switched over, and then I will start. Okay, so I'm just going to have a very quick intro here. So I am Josh Feingold from Tom Sawyer Software. I am the lead solutions engineer here. What that means basically is that I handle most of the customer-facing engineering efforts for Tom Sawyer Perspectives and for our other products. That means development of examples like the one that we're going to be showing today. working on services, taking the concerns of customers and their requests for new features and bringing them to our product engineering team. So a whole variety of tasks that basically involve us engineering and someone getting what they want. So Tom Sawyer Perspectives has a design, preview, deploy. We'll cover that paradigm. We'll cover it in a bit more detail as we go. But basically, we take data from wherever it lives. Can be structured, semi-structured, or unstructured. We put it into our model and data integration layer, which in this case means taking your graph from Neo4j, bringing it into a Java application memory layer so that you can work with it, and then on top of that, stacking modeling, visualization, interaction, and analysis so that you can take your data and turn it into something that is not only of a pleasing form, but that is also of a pleasing aspect, right? So if you can think about this as two steps, we have data into graph, and Brian was pretty modest there. He didn't mention that this started out, this data set started out as 500,000 lines approximately of an Excel file that we got from a U.S. Government data website. Opening that file in Excel, just opening the file takes between 6 and 8 minutes on my laptop, depending on what mood my laptop is in. So it's quite a hefty data set. And we're going to kind of show you what the combination of bringing it into Neo4j so that you can leverage the Cypher query language and then adding a visual front end can combine to give you. So what we're going to end up with is a definition of a project. So a definition of a project starts out with a schema. So here, all of the types of data objects that we saw described in the CSV, and then subsequently in the Cypher queries that were written to import the data, we're seeing here. So we have model element types. There are areas, states, flows, and commodities. We have some additional metadata attributes that are going to be derived from the subset that we take. And here we have some Neo4j queries. So here is a lookup for all of the areas. Here's a lookup for states, and here's a lookup for all the commodities that exist, right? And so these are all very easy, and these are the types of queries that would be relatively easy to write, even against a SQL database. What gets a little more complicated and a little more interesting is over here, where we're going to find all the flows that exist between the individual areas and with the individual commodities that we're particularly interested in. Right, so here is a bit of a more evolved Cypher query. You can see that we're using a lot of different types of traversals, from states to exports to imports. These types of where clauses and flow-specific information are the types of things that do get very difficult to write if you're using a relational database, but that are pretty intuitive to write in Neo4j with Cypher. So without dwelling too much further on that, I want to show you kind of where we're headed. So we've designed this application, and we've built in a lot of intelligence related to writing Cypher queries. And what we end up with is a final web application that looks something like this, where instead of our end users having to be very knowledgeable database experts who are going to need to write Cypher query language, and Cypher query language is great if you're a guy who knows a lot about databases and who knows a lot about the data, but if you're not, it can be a bit less useful to you. So here we have a query that we've run that has pulled out every state, and every region within every state, and every type of commodity that we have within our within our data set. And let's say that I'm interested in, for example, the flow of agricultural products around, the part of the Midwest. So maybe we'll look in Illinois and Indiana and I don't know, maybe let's say Kansas and Missouri. And then we'll just look down our commodities here. So we've got live animals, cereal grains, agricultural products, animal feed, meat and fish, and let's say prepared foodstuffs, right? And now we're just going to run this query. So now we've populated the query using Cypher. We're going to access its attributes, and then we're just going to run it. Let's see. Oh, looks like my browser is stuck. Let's reload this. Here we go. So Illinois, Indiana, Kansas, and Missouri, and we'll just pick all those products again, and we'll run. There we go. Got my browser unstuck. All right, so now we've seen that these commodities have been populated over into the left here, and now we have used the full power of the Cypher query language, and we didn't read 500,000 lines out of an Excel file. We just looked into the graph, and we found the types of relationships that we were interested in, and we can come up with a chart to characterize it. Okay, so we've got so the imports and exports for Illinois. We can look at them for Chicago. We can look at Kansas City, Missouri. We can look at St. Louis, and we can look at a map. So not only can we get them in a chart view, we can get them in a geographical map where we can see, oh, this is how each of these types of commodities is moving around the area, right? So we've got Kansas City, Missouri. We've got Kansas City, Kansas. And we can view it as a topology, right? So this topology is able to represent all of these flows between each of these different areas with a fully dynamic, customizable, automatic layout. So we haven't stored this graph anywhere. We didn't know that these were the particular commodities that I was going to pick, or that these were the areas that I was interested in. This is just automatically finding each of the relationships and each of the areas and drawing everything that we're interested in seeing, right? So we can see this is a hierarchical flow here from left to right. You can also see it as a type pack orthogonal schematic. Right? And you can see that this is a pretty complicated diagram to draw, a pretty complicated diagram to read if you're going to view it statically, but fortunately we don't have to read it statically, we can read it interactively. I can mouse over this edge and see, this is the other prepared foodstuffs from Chicago to another area of Chicago. We can see that it's $467 million in trade. Here's 469 million. This is meat, fish, and seafood. Here's 552 or 775, and each one is color coded. So we can zoom out, and in fact, we can do things like select each type of commodity. So here's my live fish and animal edges, right? So if I want to find all my live fish and animals, I want to find all my cereal grains, I want to find all my other agricultural products, etc. So now we've taken this data, which was 500,000 lines in a spreadsheet, right? So not useful to anyone. We've converted it into a Neo4j data store so that now we can actually access it. If we're smart, right? We can write a Neo4j Cypher query. We can get in there and we can get exactly what we're interested in, and we can get it in a timely fashion. And then we've gone one step further and we said, okay, so I've gone from data to graph, and I want to go from a graph to a visualization so that I can look at this and I can understand it, and so that I don't have to be an expert in databases. All I have to be is someone who knows what I'm interested in, right? So if I work at the Farm Bureau and I want to find out about these particular attributes, then I can do that. And let's say I'm not really interested in any trade that's worth less than, let's say, $200 million. So now I've simplified my graph. And I can do this dynamically. So again, I can update my layout. I can view it as a left to right flow. I can view it as a schematic. I can view trade clusters that exist within my graph. And I can also see things like, oh, well, this is the only pink edge that I have here. Well, what does that mean? So it turns out that Indianapolis sends a great deal of other agricultural products to the remainder of Indiana, but none of these other areas have that attribute, right? So you can definitely see some very unique attributes of this drawing very quickly, right? So we can view it as a schematic. We can reintroduce this. So maybe I want to go from 200 down to 100. We're going to reintroduce all these edges. They're not going to look like anything because we haven't laid them out, but we can very easily do that and update our drawing accordingly. Right? So we have this very dynamic, very interactive view on our data that we've leveraged power at every single point in the process. And we can also go over and view these in a table, right? So if I say, okay, so here's an edge, I like this edge, I'm interested in it, why don't I go view this in the table? So, obviously tables are not the best way to view 500,000 lines of anything. But for this couple dozen lines, maybe there are things that I can learn here by viewing it this way. So okay, well, this stands out. This is my animal feed product. Maybe I want to go back and view this edge in my chart or in my graph, or can view it right over here in my geographical map. And we can control areas. So let's say, well, I'm not really interested. I'm only interested in urban areas. So I'm gonna unclick Illinois. I'm gonna turn off the remainder of Illinois. So now I'm showing Chicago and I'm showing Naperville. Turn off remainder of Indiana. Turn off remainder of Kansas. And now we can, just as we filter down on the values of edges, we can also filter down on other types of information, right? And we can search. So let's say I want to find, fish. So here I've found all my commodity flows that include fish, and I can individually navigate between them. Let's say, this is the one I was looking for. And again, this is all coordinated back to the single data set. So we can see, in this chart view, we can see all of these, this contents of the chart equally acting to reflect changes that I make in all of my selections, right? And so this is fully interactive. So we're not constrained, and I want to kind of drill this home that it's all about having useful interaction. So so we can have coal, gasoline, fuel oil, petroleum products, and maybe we know that there's a lot of coal oil. Obviously, Texas has a lot of fuel. Maybe we're interested in seeing what goes to Nebraska or Iowa, and we want to pick up Pennsylvania as well. Run a new query. And now, just like that, we have a completely new graph, and this is the exact same application. We're following all the same rules that we followed before to discover what was interesting to us, but it doesn't necessarily need to be the case that you have to build a whole new application when you transfer from being interested in farm goods to being interested in petrochemicals, right? So we're just going to dive back a little bit more into the technical aspects, just very briefly, before we wrap up. Just so that now you've seen where we're going, that'll give you a little better context to understand what's going on over here. All right, so we talked about the schema where we said, okay, we've got areas, we've got states, we've got flows. We know how we saw those. Here we have areas and states and images and states and image-based ones, so you can have different UIs, right? So we can have a state house to represent a state, or we can have a little neighborhood to represent an area. We can have straight and curved edges, so we can actually modify that as we go. So if I go over to this the settings tree, I can change my edge types from straight to curved. So depending on exactly what you're doing, what's going to be visually pleasing. I can change my hierarchical layout direction. So instead of going left to right, I can go top to bottom, do the layout again, and we've moved everything around. All right. I can change my routing style to be orthogonal, switch it back to straight edges, perform a new layout, and now we have an orthogonally routed layout that again follows all these rules that guarantee this very nice tight packing scheme, but no overlaps between these objects, right? So this is all configurable at runtime, depending on what it is that you want to expose to your users, so that they get the most appropriate experience for whatever their knowledge is, right? So we've taken away all of the deep technical knowledge, we've taken away all of the jargon, and we've just used the power of data to graph to visual front end to really expose to people what it is that they want to see. So again, just very briefly touching on some of the approach that we had here. For our trees, we use rules. So for every area, for every state, we're going to add nodes and leaves to our trees. Similarly, for drawing, for every area, we're going to add some actions. For every flow, we're going to add some edges. For the map, we're just going to add, very simply, we're going to add a marker and set some properties. And for every flow, we're going to add an edge with some properties, right? So here we can control all of our filters. Here we can control all of our searches, so that all of this maintains its data-centric attributes, so that when I click over here, I'm not just selecting a particular edge, right? It's not just an edge in a graph. This is actually a commodity flow, right? It's got all the attributes associated with the commodity flow. I can see it in the table. I can see it in the map. And I can see, each of the areas in the chart. So, if I want to click on Texas, I can see Houston, Texas, because I selected it over in my chart view. So that's a very quick overview of the type of power that you can get when you actually let yourself utilize this paradigm of going from data in an unusable form to data you can traverse in a graph to data that you can leverage from a graph and get a really nice visual front end that anyone, even someone who isn't an expert on graph databases, can really utilize to its full potential. All right, so Greta, if you want to take it back, I think we can open this up for questions.
Awesome. Thank you so much, Josh and Ryan, for that great presentation. Attendees, now's the time to type in your questions in the questions portion of your GoToWebinar control panel. While you're doing that, I do just want to remind you again, I know Ryan mentioned it, but we do have Graph Connect coming up. Tom Sawyer will be there as well, so you can see this all in person. It's going to be October 21st at Pier 27 in San Francisco. We're expecting tons of attendees, so get your tickets now to be able to talk to the rest of the graph world. We also have a lot of Neo4j events happening all the time, all around the world. So check those out at neo4j.com/events. All right. Okay, so our first question, is it possible to change data in the visual view and update it in the database connected to Tom Sawyer?
Yeah, so I guess this one is for me. The answer is absolutely. Depending on, so Tom Sawyer, obviously we love working with Neo. The query attributes are great, but we actually work with a whole variety of backends if you have other things that you want to work with, even alongside Neo, right? So we can write back to a whole variety of different data sources. So one thing that we see sometimes is that Neo is providing the topology view. There's some supplemental data source. Maybe they've got some very static data that they keep in a SQL database that they want to use alongside. And you can actually use those together, right? So it lets you even add power onto Neo at the front end level, because obviously Neo is very, very good at some things that SQL isn't.
Yeah, and I guess, Ryan, can you talk a little bit more about kind of Neo's interaction with other databases? Like, I mean, is it possible to
Sure.
connect multiple databases?
Yeah, we find people using Neo4j oftentimes by itself, but we also find people using it along with other databases in what we call polyglot persistence. And what that means is that people are using a database for what it's best for. So in the case of one of our customers called Wanderu, they receive a lot of data from different data providers as JSON documents. And they store those JSON documents in Mongo, and then connect their Mongo database to Neo4j to enable them to query on the relationships. So they find the relationship queries very hard and inefficient to do in Mongo, but by taking that data and synchronizing it with Neo4j, they're able then to query on the relationships between their data points. And so we have people doing it, with Mongo and other NoSQL data stores, but we also have people attaching Neo4j to their traditional relational databases as well. Store the data where it's best to store the data, query the data where it's best to query the data. We definitely believe in that. We believe the answer often is that the best place to store and query the data is Neo4j and graph databases, because they're intuitive and faster and that sort of thing. But there are times it's not. So we are willing and happy to help customers in finding good solutions to the polyglot persistence challenges.
Awesome. And that actually seems like that's all the questions that we have today. If any attendees on the line do have more questions, you can always email us at webinar@neotechnology.com, or tweet at Neo4j or at Ryan. We'll be sending out the slides with the recording. And so any questions that you have, you can either respond to that email, or both Ryan and Tom Sawyer's Twitter handles will be in the slides. So yeah, thank you all for joining us today. Thank you to Tom Sawyer, to Josh, for being here with us.